I'm ready to go. So you might wonder what Dr. Slime is doing at the zoo. I'm here to have a blast. We're gonna do a liquid nitrogen explosion. So please, camera people, back up to 30 feet. Maybe a different angle. I'm gonna start filling my container right here. We're gonna back up because this is gonna explode. It's full of liquid nitrogen. And what's happening right now is the pressure is building, just like the excitement for the kids that want to come to Zubu. And so, as the pressure builds, it gets bigger and bigger and bigger. And there she goes! You catch that? Yeah. Have a blast! What we're doing here is we're getting ready to decompose. Isn't that a cool thing to do when you think about Halloween, decomposition? So I'm starting with a superatom. This is hydrogen peroxide. It's just like water, except it has an extra oxygen molecule. Now, in order to slow it down so my cameraman doesn't get coated, I'm gonna add some soap. This is my special Dr. Slime green soap. I'm gonna put that in there, a couple of squirts of soap right in there, and in just a second, my pumpkin is gonna get ready to erupt. Now, my third and final component, potassium iodide. When I add this, it's gonna reach in and grab those hydrogen peroxide molecules. It's gonna snip them apart. They're gonna decompose, and all kinds of oxygen gas is gonna come shooting out and making a frothing mess. Please stand back and stay tuned. Here we go. That frothing mass right there is oxygen, soap, and foam, and water. And in just a couple of seconds, it'll all start to continue its decomposition process. The oxygen will go up in the air, the soap will be used to wash the sidewalk clean, and it will all go back to normal. My pumpkin, of course, he looks a little messy. Our special guest. Special guest today is Big Tasty. Big Tasty is this white-ish salamander you see in here. He's in Bistaba mexicanum. He comes from a family of axolotls. Now, the wild type of axolotls are under severe pressure right now because of habitat loss. Their habitat in Mexico City is currently disappearing. It is thought there's only 200 of the wild type of these left right now. This is a very special one. He's been genetically modified, and a special gene was inserted so they could study his regeneration. Now, the gene that's inserted in Big Tasty here is a glow fluorescent protein. Big Tasty is a salamander who has gills. He's kept his juvenile feature, and he's a big white salamander. Now, here's his special feature. There's Big Tasty. He eats minnows and bloodworms and lives in my aquarium. And if we bring down the lights, I can show you his special feature. Big Tasty glows. Do you see the glow fluorescent protein in his body? That makes him glow green like that, just like a jellyfish. Now, he lives in a large aquarium at my house, and I've raised him ever since he was just a tiny little salamander. And when I purchased him, half his tail was missing. But you notice he's got a whole functional tail now. And that's because Big Tasty comes from a group of animals, amphibians, that regenerate. Big Tasty is just visiting with Dr. Slime here today, And he's one of the neat things. If you like animals, you'll love the Children's Zoo. What I have here is some swamp water, and what we're going to do is we're going to add some chemicals to it. Now the first thing I want to do is I want to grab a little bit of universal indicator from my tackle box over here. Of course, I always seem to forget something, but that's just Dr. Slide. So we're going to start by adding a little bit of Dr. Thompson's universal indicator. This is a special chemical which tells you what's going on in the solution. Now you might use this if you have an aquarium or a hot tub to see what the pH is. pH is a condition that whether the water is acid or base. Now notice how my indicator is green. See that dark forest green? That means it's neutral. That's the kind of water my axolotl likes. Now, we're gonna add a little bit of baking soda. So we got this little container here of baking soda, NaHCO3. We're just gonna shake it in there, and we're gonna give it a little jiggle. Now, I want you to notice what happens. As we shake this up, that white powder disappears. Now, some kids will say it's disintegrated, and other kids will say it's dissolved. I want you to think, which one? Disintegrate, dissolved. Type it in, put it up there, tell me whether it disintegrated or dissolved, and Dr. Slime will pop in later and see who got it right. Now, we've got the baking soda in there. Now we're gonna add this stuff. See this label, see how it's burned? It says sour yak belly juices. The chemical is so powerful, it burned the label. This is stomach acid. The same thing that's in my axolotl's tummy that helps him dissolve his minnows that he eats, and the same thing that's in your stomach. Now, if you eat too much candy at Halloween, you can trick your stomach into making too much acid. Watch what happens when I add the acid to my flask. Do you see it start to fizz? Back up just a little bit, because it might pop. Oh! Holy mackerel, did you see that? Did you see the lid blow right off? It shot clean off. That was gas coming up. What do you call it when gas comes up on you? A burp, that's right, I heard you say it. Now, we've just watched the gas blow that stopper off. So I'm gonna take this glove and I'm gonna put it, first I check it for leaks, and then I'm gonna put it inside my flask. And I'm gonna see which way the air goes. If more air shoots out, the glove will pop up. If the air in the room swirls and goes inside, the glove will inflate. What do you think it's gonna do? Will it blow up or will it blow down? We're gonna measure out our next chemical. This is sodium hydroxide. It's a very powerful chemical. Your mom uses it to clean the oven. And you should wear gloves or be very, very careful whenever you use sodium hydroxide. It's also used as toilet bowl cleaner. Now watch what happens to my universal indicator when I add the sodium hydroxide. Do you see that color change? Do you see it changing purple down here? That deep purple color? Now we're going to insert that glove, and then we're going to seal it down with this little rubber band. Now remember, we're watching to see which way the air moves. See, we already saw the air jump out and blow the stopper off. We're going to put this rubber band out there real tight. We're going to shake it up now. Watch and see. Do you see the glove starting to blow up? Or is it blowing down? It's going inside. And the more I shake it, the bigger it gets. Matter of fact, you could even peek right here inside the bottle. You can look down into the fingers. Have you ever looked inside a balloon? What happens when you look inside of a balloon? All the air comes blowing out. But look, this is blown up just like a balloon. How come the air doesn't come rushing out of that? Isn't that weird? Well, I had one boy tell me it's because a ghost has his hand caught inside the jar. Do you think that's true? Well, we're going to take off the rubber band, and if there's a ghost, he might come out. However, if it's a scientific explanation that maybe there's a vacuum inside the jar, oh, by the way, look at my purple, it's turning blue. The glove will get sucked inside. You ready to see? Here we go. On the count of 3, I'm going to let go. You see what happens. 1, 2, 3. Oh, it's being teasy. I've never seen it go this slow. I'm going to have to give it a little nudge. This has only happened to me once before, where the forces were perfectly balanced. Do you know how hard it is to get the forces of air perfectly balanced like this? It's almost impossible. Almost as hard as freezing a bubble. I've done that twice. It's really cool. I haven't run out of things to do. I keep thinking about all the kids I'm going to miss this year. Hey, how you doing? Can't wait. I'll be here in spirit. Maybe one of these days I'll even sneak out here. Get your tickets. So, in this jug, 4% polyvinyl alcohol, 96% water. We're just going to pour that in here, and as you can see, it's thick and oily. This is the base for Dr. Slime's slime. Now, that thick, oily liquid has long, invisible chains in it. And what we're going to do is we're going to polymerize those chains. We're going to hook them together with the miracle chemical that's in here. It's called borax. It's found in Death Valley. They mine it and they put it in a box, and you can go to Meijer's and buy it as 20 Mule Team laundry detergent. Once you dissolve 20 Mule Team laundry detergent in water, the borax, when it's in a 4% state, will act as a cross-linking agent. I like to think of it as a spider with 4 big hooks that reach out and grab those invisible chains drifting around in the water, and then it transforms it into slime. So now I'm going to add the borax. Now you might notice that the borax glows when I put a black light on it. See that glow? It glows just like an axolotl does. Chemicals and animals that have a fluorescent molecule in them can trap UV light and change it. And my slime will glow the same way. Now we're going to add the borax and a little bit of fluorescein. That's that green color, Dr. Slime's favorite color. We're just going to whip it up here with my spoon, and it'll start getting thick. And as it gets thicker and thicker and thicker, those borax molecules are finding those polyvinyl alcohol molecules. They're cross-linking together. Remember, this is 96% water. A glass of milk or Coca-Cola has more solid stuff in it than this does. Let's see how it turned out. Here it comes. Oh my gosh. There's Dr. Slime's slime. Oh, it's dripping all over the place. It looks like a giant elephant booger. Look at that. Isn't that cool? And that's chemistry. Polymerization is the same way plastic is made. The chair you're sitting on or the steering wheel in your car are all made by chemistry. I like other things besides chemistry. I love animals and I love the zoo.